In the very last video about linear absolute inequalities, we're going to try to shed some light or think about the various applications of these inequalities. So let me write down the title: Applications. It might be a bit long, of linear absolute inequalities. Inequalities. It's a rather a mouthful, so let me put it into some kind of bubble. The first one that I'll make a bubble right here, I think I'll divide it into three. Is a classic example of a greenhouse. So we have which I used a red color, I'm aware, of a greenhouse. I will really try. So let's say that we have a simple greenhouse where we have plants, which I will really try to simplistically draw right here using a rectangle. And inside we have some kind of plants. So I really bad at, well, I'll just draw a couple of plants, maybe some tomatoes. And the person that knows how to grow will say something like this, that the temperature, and I'll go thicker, the temperature must be around, let's go with 25 degrees, okay? 25 degrees. And then also saying that we're going to ask how much. So this is the first point, and it can move, it can be off, let's say by 3 degrees. So somewhere along the line. So we have 3 degrees and 25 degrees. Now, surprisingly, this is absolute linear inequality. So how are we going to write this equality? Firstly, what is our variable? Our variable right here for our greenhouse problem for tomatoes is temperature. It's not x anymore. It's temperature, which we will write down as T. Now, what are our limits? Now, we must be around. So around, when we hear the word around, it can be plus and it can be minus. It can be plus, it can be minus, above and below. Now, what does that have to common with absolute functions? Well, that it's an absolute function. Because if we would put around, absolute value plus 2 is the same as minus 2. So when we hear the word around, we can think of an absolute problem in mathematics. But let's write it down. So right here, we know it's absolute brackets. So right here, we have absolute brackets. We're going to have the variable T as temperature. And it will probably be, so question is if we want smaller than or larger than. So we want to make sure that it doesn't go more. So it can't be more than a 3-degree difference. So it can't be more than, let's say, 25 plus 3. So it cannot be more than 28 degrees. Okay, so this would be bad. So we're looking for the numbers that satisfy smaller than. So the symbol we will use here, and let's say I can include the number, is smaller than or equal to 3. And here we would have the minus 25. And this is how we would represent our inequality. Yeah. If we would draw this, so we're going to try to draw this here. So let's say that This is the temperature. And this is the difference that the device, let's say that there's a device that opens windows. I think that makes perfect sense. So here we have some kind of a window. Let me also draw a very, very simple, I don't know, window that let's say it can open and close. And there has to be some kind of sensor that can say, hey, if let's say it's more than 3-degree difference, open the window. Open. So it has to calculate. So this is the let's call it a I think I'm just going to write it down. So this is t minus 25. So we're going to draw that. And then we have a difference of 3 degrees. So it is essentially something that can be, well, it doesn't exist. So it's shifted. So how do we draw if you remember how we drew the function x minus 2, it means that it shifts towards the right. So this function will be shifted also towards the right by a temperature of 25 degrees. Right here, so temperatures in degrees. We have x. So we want to draw the function. So let me plug in a temperature of 20. Let's go with just a temperature of 20. This will not be to scale. I think I'm not going to plug in. Simply, it is 45 degrees. So go something like this. Yeah, this is the same thing. So this is our function if we have y equals t minus 25 and smaller than 3, our condition for our computer is that we have that the temperature, and this is equal to 3. Now we have these 2 points, which I think are rather obviously, this point is 22 degrees, and this point is 28 degrees. So for all the numbers that the temperature is here or here, for all the temperatures, so between if the windows would open, Windows would do something. Let's say Windows would do something. Simply that, and that the temperature is not ideal. Yeah, temperature is not ideal. I explained it rather chaotically, but hopefully you can see how it can be applied. And we have 2 more examples coming up very soon.